Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter thermal properties of metal. Okay, so let's start the video. Question is, a cylinder of radius r is surrounded by a cylindrical shell of inner radius r and outer radius 2r. Okay, now let's see. The thermal conductivity of the material of the inner cylinder is K1 and that of the outer cylinder is K2. Assuming no loss of heat, the effective thermal conductivity of the system for heat flowing along the length of the cylinder is how much here? Okay, so this is the question. So here you can see very well. There is one cylinder is there. Which color? Here we have represented with the white color. Thermal conductivity of this cylinder is how much here? K1. And let's take this one is having area A1. Okay, this one white color, this is having area A1. Okay, now what is happening that here? This solid cylinder is surrounded by one cylindrical shell represented by which one? Pink color. And let's take here, this shell is having this cross-sectional area. A1 is also cross-sectional area. A2 is also cross-sectional area. Okay, and what is the thermal conductivity? It is the K2. And according to the question, we can see here this solid cylinder, that means inner one, is having radius r. And if we talk about here this shell, cylindrical shell, so you can see very well, inner radius is r, outer radius is 2r. So if I talk about here the total radius from this center to outer one, the total radius what is given here? 2r. Even if we see from this side, cross-sectional area will look like a water circle. So you can see very well this radius r, so this radius also r, white color. And this total radius how much here? 2r. So here also how much here? 2r is there. Okay. So now students, we have to decide whether these two cylinders, they are connected in series or parallel. So according to the question, they told that the heat is flowing along the length. Okay. So this length is there. Now this yellow color. So when the heat is flowing along the length, so let's take heat is represented by Q. So you know very well the heat always flows from where to where? From the high temperature to the low temperature. So let's take here, this end is having the temperature T1 and this end is having the temperature T2. This system in a steady state situation, that means temperature T1 is always constant, it will not change when the heat will flow, and T2 is also constant when the heat will flow. But what will be there? This T1 should be always greater than T2. T1 is constant, T2 is constant, but T1 is greater than T2. Why? Because heat will flow from where to where? High temperature to the low temperature. Now you can see very well, see, this inner solid cylinder is having how much temperature difference? T1 minus T2. If I talk about here the outer cylindrical shell, how much temperature difference? T1 minus T2. So you can see very well as the temperature difference for both the cylinders is constant. That means they are connected in a parallel. Okay, remember that here. In an electrical system, when the potential difference is constant, they are connected in a parallel. But in this thermal system, when temperature difference is constant, then only they are connected in a parallel. So we can write here, see, as T1 minus T2, what is there? As T1 minus T2 is constant. Constant for two cylinders. Inside one is solid one and outside is the shell. Okay, it's constant for two cylinders, hence they are connected in parallel. Okay, they are connected in parallel. So now just guess what is the resistance formula in parallel. So in a resistance, equivalent resistance formula for the parallel, the formula I can write here. Let's take here, the formula is given here. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Is it? So you know one formula very well. One formula you know very well. R equal to rho L by A. What is rho? Resistivity. So when I will convert into conductivity, so 1 by sigma L by A. Okay. So this formula we have to use when we are talking about here the electrical resistance. But here we have to talk about here the thermal resistance. That means this electrical conductivity have to replace with the thermal conductivity. Okay, so everything will be same, but I will use this formula. The formula will be what? R equal to L by Ka. This formula I will use here. Why? Because this is for thermal. I am writing here, this is for thermal and this is for water. This is for the electrical. As in the question, we have to talk about water. We are solving this question for equivalent thermal conductivity. That means here I am going to get one cylinder like this. One cylinder will be there, okay. This cylinder will have the, maybe dimension wise I have drawn somewhat less, but remember that here, if in case here the length is L, remember that here, if this length is L, so here also this cylinder should have how much length? L, okay. And what about the area of cross section? This area of cross section will be how much here? A1 plus A2. That means dimension wise both the cylinders will be same, but here you can see very well thermal conductivity K1, here K2. So instead of two materials, here there will be the only single material, okay. And this one will have thermal conductivity how much here? Let's take K equivalent, okay. So what can I write here? You can see very well R equal to L by Ka. So what is 1 by R? Ka by L, okay. So I can write here, see, K equivalent into area of cross section, what will become here total? A1 plus A2, okay. That means a cylinder of single material going to replace the given system. By length how much here? This one is L, this is also L here, okay, is equal to, here I can write here what? See, for the inner one, see, K1 A1 by L, length is same, plus this one, this pink color, what is given here? See, K2, this pink color area how much here? A2, length anyhow same only. Now you can see very well what other things will cancel out. This L, this L, this L cancel, okay. So we can get here the formula. The formula is what here? K equivalent is equal to what? K1 A1 plus K2 A2. Even if you remember the formula, directly we can solve this question. But first we have identified whether they are connected in series or parallel, okay. Now variously we have to just put the values. No? So let's take here. K1, what is the K1? K1 is given here. A1, what is the A1? You can see very well this radius is R. From this side it will look like a circle, so we have to write here pi R square. Similarly, to get this A2, that means pink color area, what we have to do? From the total area of this, we have to subtract this inner area, then we will get here the pink color area here. Okay, so kindly see here. Now, so now let's see here. We are just going to put here the values. Okay, so here what is going to happen that here? Let's see here. So here we can write here, see students, see, K equivalent is equal to K1, okay. And what is the A1? That means that white color, that is what is there here? Pi R square plus K2. After that, to get that pink color area, what we have to do? First we have to get here the full area, total area, total area. Total area means how much here? This is the radius 2R. So we can write here, see, pi into 2R square minus. From this overall area, we have to subtract this white color area, then only we'll get here the pink color area, okay. So we can write here, see, pi R square. And total area, any how much is there? See, total area means A1 plus A2. That means overall area. Overall area how much here? Radius is 2R. So we can write here total area is given here what? Pi into 2R whole square. Is it? Now let's simplify this here. So you can see very well. Let's simplify. K1 pi R square plus K2. What this will become? See, 2R whole square, na? That means 4 pi R square. 4 pi R square minus pi R square. This will become here 3 pi R square. And here we can write here pi into 4 R square. Okay. So what are the things we can take common? So let's take here pi R square is common. So when I will take here pi R square common, let's take here K1 and this will become here 3K2 by, we can write here, see, pi R square into 4. Now let's see here very easily what other things can be cancelled out. This pi R square cancel. That means the K equivalent value what is coming here, see, K1 plus 3K2 by 4. This is the equivalent thermal conductivity. So remember that here, as this equivalent thermal conductivity depends only upon the material. So whenever we are going to find out this equivalent thermal conductivity, dimension should be same. Maybe you can see this is the bigger cylinder, this is the smaller cylinder, but this one we have just written just for the example, but remember that both are having the same dimension. This L, this also L. Here area of cross section A1 plus A2. This is also how much here? A1 plus A2. Here ideally I should have drawn here this one and this one same size, but due to the shortage of the space, I have just written like this is there. Okay. So what is the correct option is there? You can see here K1 plus 3K2 by 4. Okay. So students, I hope so. This video based upon the heat conductivity, thermal conductivity based upon the conduction mode is very, very clear to you. Keep studying, keep going.